Hello, friends. Welcome to my channel, Academic Made Easy Peasy. If you have not subscribed my channel, subscribe it and also click the bell icon. In the previous video, you will be just seeing about continuity, and I think you will be clear with the term or the topic continuity. So now let us move on to the main topic and the most important topic, where you will be getting 6 marks or 4 marks or 2 marks, 1 marks. In every part, this differentiability is expected. So you have to be very thorough with differentiability. So differentiability is one of the most important as well as the very easy topic. Okay, so you have to be very clear so that you will be able to attend any type of the questions that is asked. So now let us move on to learn the differentiability. So before giving you all the example or before teaching you what is differentiability, let us learn a definition for differentiability. So here it is given, if f is a real function, that is with some real numbers, so the function which has real numbers or real values, then it is called a real function, and c is a point in its domain, then the derivative of f at c is defined by f. This will be read as f dash of x, okay, or the differential of this x. Okay, so f dash of x is equal to limit h tends to 0 f of x plus h minus f of x by h. So this is the formula which we will be using in order to find some functions, that is mod function, like trigonometric functions. For those functions we will be using this. So while doing the exercise, I will just teach you how to differentiate by doing it directly or by using any rule or other things. I will just say you while we do the exercise sum. So now have this formula alone in your mind. So now see a differentiability. So y is equal to f of x. This we know. This is a function. We know it already. So what is the differentiability means? Here it is given. See, y is equal to f of x. Now, so this is the function. So we have to differentiate this function. So what we do is that the differentiation, this one is written as y dash. So y dash is equal to f dash of x, or else we can write it like this also, or else we have one more type, that is d by dx of y is equal to f dash of x. For example, let me give you an example. So with that you will be clear. You have already learned, but still let me give you all an example. So I am writing y is equal to x square plus 1. Since you know it already, I will just rush. Then if you have any doubts, you can just mention it in the comment box. So my function is y is equal to x square plus 1. That is y is equal to f of x. No, so that only I am writing it as x square plus 1. Okay, so I will be writing it as y dash or d by dx. Okay, mostly we will be using d by dx only. So I will be writing dy by dx. If you write like this also, it is right. If not, dy by dx also is right. So my x square, so we have already learned. So differentiation of x power n is n is equal to n into x power n minus 1. So this is a formula, no? So what is my n over here? It is 2. So I will write 2 over here, and my x as it is. Okay, and 2 minus 1. So n is 2 here, no? So 2 minus 1 is 1. So 2x power 1. So here I have constant. So differentiation of any constant is 0. So I can just leave like this. So therefore dy by dx is equal to 2x. This is my answer. So we will learn it detailedly in the exercise. So now you have to understand what is differentiability. That's it. So we have already learnt in continuity, that is LHL and RHL. No, so here for derivatives also we have LHD and RHD. That is left hand derivative and right hand derivative. So here the same thing what we learnt in continuity, the same thing is applied over here. Okay, so here LHD, we write it as LHD. So limit, I said no, we will be having a point over here, and this will be our left hand derivative, and this will be our right hand derivative. So that when the point is over here and we have to move backwards, so what should we do? We have to subtract. So that is what written over here. H is tending to 0 minus. Okay, at that time what we will have, f of a minus h minus f of a by minus h. So here minus h will be there. So when h is tending to 0 minus, then we will have minus h. Okay, so RHD will be limit h tends to 0, f of a plus h minus f of a divided by h. So I said no, for left hand derivative h will be minus h, and for right hand derivative it will be positive of h. So that is what the only difference here. So the function is differentiable if and only if LHD is equal to RHD. Okay, so if you have any doubts, you can just mention it in the comment box. Okay, I think you will be more clear. Next, algebra of derivatives. So this also we have learnt already. Okay, if you want any examples also, let me give you. So u plus or minus v the whole dash, that is the differentiability of that is equal to u dash plus or minus v dash. So let me have it as x square plus x. Y is equal to, okay, so y is equal to x square plus x. So this only I have to differentiate. So what will I do? So I will be taking it as dy by dx is equal to, this one will become 2x plus 1. So this is what the thing. So x square, differentiability of x square and differentiability of x I have taken. So now let us see for subtraction. So y is equal to, let we have it as 3x plus 4x square. Okay, so I will be taking dy by dx is equal to, for this it will be 3. Okay, so we are taking it over here. Sorry, this should be minus, no? Let this be minus. Okay, fine. So here it is minus. So again we will be taking this differential only. No, we will be taking derivative for this. So it will be 2 4s are 8. So minus 8x. That's it. So this is what. Okay, so I think you will be clear for addition and subtraction. Here the next one they have given here is that product. So product of a function is given and we have to find the derivative of that. So let me give you all an example. So let me take my y is equal to x square plus 1, and let this be my u, and my u v, let it be 2x. Okay, so this is my u and this is my v. So I have to take the differentiable, that is the derivative of this. So what is my formula? So uv the whole dash is equal to u dash v plus uv dash. Yes, so what I will do is that y dash or dy by dx as, so first let me take the differentiable of this. So what is the derivative of this here? X square will become 2x and plus 1 will become 0. So let that be as it is. So my u dash is over. So what is my v now? 2x. So 2x should be written as it is. Okay, next what should I do here? UV the whole dash. So U is, I have to write my U as it is, so x square plus 1, and my V dash, I have to take this V dash now. So 2 as it is, and my x will become 1, so this will become 2 as it is. So Y dash is equal to 2x into 2x is 4x square, plus I will be taking this 2 inside, so 2x square plus 2. So what is my final answer here? It is y dash is equal to 6x square plus 2. So that's it. This is my answer. So uv the whole dash will be written like this only. Now u divided b the whole dash. So here it is for division, which is equal to u dash v minus. So here it is plus, no. So here for division it will be minus uv dash divided by v square, that is the denominator square. So now let us see an example. So let me have my y is equal to x square plus 1 divided by x. Okay, so this is my function, given function. So what will be my y dash? So first I have to take my it as u dash v minus uv dash divided by v square. No, so this is our formula. So my v square will be, so that is y dash will be, what is my u dash? It is 2x. Okay, you know y, and my v is x minus here u as it is, that is x square plus 1 as it is, and my v dash is 1 because it is x, divided by v square. What is v square here? It is x square. So y dash is equal to 2x square minus x square minus 1 divided by x square. So I'm not able to write x square here, so let me write it over here. So here my y dash is equal to x square minus 1 divided by x square. So you can also write it as 1 minus 1 by x square. So your y dash is this. Next, we'll see about some derivatives of the standard formula. So this I've already said you, d by dx of f of x is equal to f dash of x. This is a general term to denote. Next, d by dx of x power n. Already I taught you in this video, no? So it is n into x power n minus 1. Next, these are the trigonometric functions or trigonometric formula we will be seeing. Okay, so let me just give you a trick. Okay, so you can just remember that sine, cos. Okay, sine and cos is related together, and tan is related to sec, and cot is related to cosec. Okay, so sine is related to cos, tan is related to sec, and cot is related to cosec. You just keep this in mind. We have already learned, but still we'll learn it once more. So d by dx of sin x is positive of cos x. You have to remember this, positive of cos x. D by dx of cos x is equal to minus sin x. See, and one more trick you can just have. See, for C, the trigonometric function starting with C alone, cos, cot, and cosec. Okay, these three starts with C. No, so whatever function is starting with C, the differentiative or else the derivative of that function will be minus only always. So if you want, in the upcoming slides you can just view it. Okay. Next, d by dx of tan x is equal to secant square x. Okay, so tan x secant square x. So d by dx of tan x is secant square x. let this cot x be aside, okay, and d by dx of secant x is secant x and tan x, okay, secant x tan x, secant x tan x, okay. Next, d by dx of cot x. Cot x, I said no, derivative of any trigonometric function starting with c is always negative. If it is tan x, it is secant square x. If it is cot x, it is minus cosecant square x, okay. And d by dx of cosecant x is minus cosecant x into cot x. So you have to relate these two formulas and these two formulas. Next, derivatives of implicit functions. So here in this exercise, no, we will be just seeing an interesting as well as a tricky sums, okay. So but this is one of the interesting also because it is tricky one, no? So we can be able to do all the sums here. Only thing you have to remember the formulas, that is trigonometric formulas. So implicit function, no, so this is one of the easy topic where you can be able to do. In this topic we will be learning trigonometric sums and all. So we will mostly what every sums will be based on trigonometry. So you have to be very thorough with all the exercise. uh, so you have to be very thorough with all the formulas, that is trigonometric formulas. So we will be just seeing the derivatives of inverse trigonometric functions, okay. So we will be just seeing the derivatives there for the trigonometric functions. So derivatives of inverse trigonometric functions. So here this one is very easy, okay. You can just look into this. Sine inverse x is equal to 1 by root of 1 minus x square. So we know that cos square x plus sine square x is equals 1, okay. So this is very similar. See, sine square x is equal to 1 minus cos square x, no. So this one is only here root of 1 minus x square. It is not directly given as cos square x, but it is given as 1 by root of x square. So why it is 1 by root of x square? Because sine inverse x is nothing but 1 by sine. Yes, so 1 by sine only is sine inverse, so only it is given like that. So you can just have like that, okay. So here also for cos, I said no, cos will always be minus, and the function starting with c is always minus. If you look here also, and for this also it is 1 by minus 1 by root of 1 minus x square, and for tan x it is 1 by 1 plus x square, that is. Next, cot square x also, it is minus 1 by x square, and for cosecant it is minus 1 by x into root of x square minus 1, and secant inverse is 1 by x into root of x square minus 1. So you can remember all these formulas and do your sum. So these formulas is very important in order to do the third exercise of this chapter. Important formula of trigonometry. In order to do the third exercise, you will need to know some formulas where you will be applying it, or in order to simplify it, you will be using all these formulas. So first one, it is sine 2 theta. So sine 2 theta equals 2 tan theta by 1 plus tan square theta, and sine 2 theta says it is equal to 2 sine theta cos theta, which we already know. If you want any tricks, you can just see the 11th standard trigonometric functions formula. So that video is given in the suggested videos as well as in the description box. If you have any doubts, you can just watch that. Next, tan 3 theta is given. Tan 3 theta is equal to 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. Next, it is cos 2 theta. Cos 2 theta is equal to 1 minus tan square theta divided by 1 plus tan square theta. So this is related to this, no? These two are related to your inverse trigonometric functions. I have taught you some tricks also in that video, so you can watch that video also. Next, it is tan 2 theta. So, tan 2 theta is 2 tan theta by 1 minus tan square theta. And next, sin 3 theta is equal to 3 sin theta minus 4 sin cube theta. Cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. So now we are gonna see a new topic, that is logarithm function. So you will be learning log in your physics and all, no? So log is nothing but it is logarithm, where we will be just doing some calculations. So that is not needed. Only the differentiation of log is needed in this chapter. So let's see only that. So differentiation of log x is 1 by x, that is the x inverse. Okay, so log x is equal to 1 by x. So log e is equal to 1. So see here, when log and e is together, it becomes 1, because log and e will get cancelled. It is just like x by x, no? So, or x into x inverse, both also same, no? So these two will get cancelled and it will become 1. It is just like that, log and e, if it is multiplied, then it becomes 1. And next, log x of pq is equal to log xp plus log xq. That is nothing but, if a function is given log of some function p and q, if it is multiplication, then we will be adding, that is log of pq, p plus log of q. Okay, so log of p plus log of q there. Next, if it is log p by q, p by q, then we divide, subtract it. Okay, so log p by q is equal to log p minus log q. Okay, then log x power n is n log x. So this is one of the important formula. This is one of the important formula where you have to know, because in the upcoming exercises, no, like 5th exercise, you will be using this formula. Mostly you will be using this formula in order to do the sums. You will be able to simplify it. Let me give you all an example. So when it is log 2x power 4x plus 1, can you differentiate it? No, so you take log. Log means what? This power, no, this will be the coefficient of log. This will become the coefficient of log. So you will have 4x plus 1 into log of 2x. And now we can differentiate, no? So this is multiplication. So you can use uv, the whole dash method, in order to find it. So I will teach you that all in the exercise sum. Next, e power log x. I said no, e and log, if it is together, these two will get cancelled. Even if it is in power, it will get cancelled. So only x is remaining. That's it. Next, derivatives of some functions, that is exponential functions, is given here. So e power x, no, so d by dx of e power x is e power x as it is. There's no change here. Next, log x is equal to, already I taught you what is d by dx of log x, so this is also over. derivatives of functions in parametric forms. So this is one of the important, because we will be just given two functions x and y. Okay, so till now what was given to us, a function y and the f of x. Now, so here what is given, x is one function and y is another function, and we have some other variable or some other function that is assigned to it. Okay, so what we will be doing here is that, so here x is one function and y is another function, and what we will be doing here is that we will be taking this as the main one and this as the main variable. So till now we will writing it as d by dx, no? So what we will be doing is that d by d theta, because theta is only common here, no? So here a is some constant. Okay, so only it is like that. So d by d theta. So now let me give you all an example in order to make you clear. X is equal to a cos theta, let me have that itself, and y is equal to a sin theta. So now I have to find dy by dx. So what I will be doing is that I will be taking the differential or derivative for this and the derivative of this. So now let me take this as dx by d theta, as we did for dy by dx. No? So I'm taking it as dx by d theta. So a constant will be as it is, and my cos is minus sin x, sin theta here. Okay, it is minus a sin theta. So dx by d theta is that. So dy by dx is equal to a into, what is the derivative of sin theta? It is cos theta. So it is a cos theta. So now what I will do is that, in order to find my dy by dx, d by d theta. Okay. So I will be writing it as dy by dx is equal to dy by d theta, the whole divided by dx by d theta. So in the next step, what I will be doing, I will be cancelling this d theta and d theta there. So now what is my dy by d theta? It is a cos theta. So a cos theta divided by, what is my dx by d theta? It is minus a sin theta. So my a and a will get cancelled. So I will have minus cos by sin is cot. So the derivative of the function is minus cot theta. That's it. If you have any doubts, you can just mention it in the comment box. So now let us see the definition for parametric form. The relation between x and y are neither explicit or implicit. So that is, explicit or implicit means what? According to us, we are just changing a function or something. Okay, that is what explicit and implicit. The relation between them can be expressed by third variable. This third variable is called parameter. So parameter means what? So this theta is a parameter over here. So as we saw it in the example, we took it as dx by d theta and dy by d theta. No, so that is a parameter. So theta is the parameter. So this theta is common in both, so only we took that theta as dx by d theta and dy by d theta. So that variable which we are taking it as the third variable is called the parameter variable. I think you will be very clear with all the derivative functions. If you have any doubts, you can just mention it in the comment box. If you have not subscribed my channel, subscribe it and also click the bell icon.
Like, comment, share, and subscribe.